All right, so let's throw it way back to page 167, number 37. F of x equals 2x minus 3. We're looking for absolute extrema on each interval. The trick is we've got these weird intervals, 0 to 2 with brackets, 0 to 2 with one bracket and one parentheses, 0 to 2 with a parentheses and a bracket, and then 0 to 2 with two parentheses. So let's see, 2x minus 3, that's just a line. So that won't have any critical points. I guess you could do the official thing and say f prime equals 2. That doesn't equal 0 anywhere, so there's no critical points. So all I really have to check are the endpoints. Except that, what does it mean to check an endpoint if there's not an endpoint? Is kind of the deal with the parentheses thing. Oh no, my camera doesn't want to focus. There we go. So let's graph these. 2x minus 3, that would be, so begin at negative 3 and go up 2 over 1. Up 2 over 1. So there's question A. So there's a max at 2, 1, and a min at 0, negative 3. Nice and easy. And the picture confirms what we said already. There's no critical points, like it's just a line. All right, from 0 to 2, but where the 0 is bracketed, so we want to include x equals 0, up 2 over 1, up 2 over 1, but we don't want to include that other, the x equals 2. So what's the max of that one? There is no max. Okay, you can say it doesn't get above 1, and that would be correct, but there's no maximum y value because of that open circle. It's like, well, it gets to 1.99, yeah, but then it gets to 1.99999, yeah, but then it gets to 1.9999999. So you can't ever get an exact answer for what the maximum is. So you would say there's no max. The min's there, that's still 0, negative 3. And then we'll skip C just because it's running out of space. D, it's got an open circle on both ends. So no max, no min. And it's that open circle thing that's throwing things off. So that's why the parentheses and versus bracket matters, because if there's an open circle at the max, then there's not really a max. I guess I'd say be careful. Does that graph have a max? So we'll just say yes without coordinates or an x or a equation. We don't know what it is, but it does have a max. Does it have a min? No, because the min would be there, but there's not there, right? Because it doesn't ever really get there. The max is whatever that point is. So be careful. And I guess another way to do it would be if we did that. So you're thinking, oh, I got open circles everywhere. I better be careful. Does this graph have a max? Yes. Right there. Does it have a min? Yep. So you can't just say, well, if it has open circles, then it doesn't have a max or a min. Like, you got to look and see what's going on. Where is the max and min? And then if it's at an open circle, then it's not really there. Or there's not actually a max there. Emma?
Can you do 41 on that page?
Sure. Uh-oh, this could be the same situation here. 1 to 4 don't include 1, do include 4. Although there's an asymptote at 1, so that would be why we can't include it. Use a graphing utility to graph the function and find the absolute extrema of the function on the given interval. So this one specifically says use a graphing calculator. But I think I can do it without. It's an asymptote at 1. I'm just going to plug in some values. If I plug in 2, 3 over 1 is 3. I plug in 3, 3 over 2 is 1.5. If I plug in 4, 3 over 3 is 1. So there's my picture for 41. Find the absolute extrema. Okay, so what's the max? There isn't one. It goes up toward infinity. This is not the answer, but it would be correct to say the limit as x approaches 1 from the right is dne because it goes to infinity. That's about as good as you could say for a max. The official answer is there's not one because it's going to infinity. The min is at x equals 4 and y equals 1. Again, if you want to just give the point, that's the safest place, or the safest way. The minimum is 4 at, nope, the minimum is 1 at x equals 4. So be careful on the vocabulary there. Anything else from 167? I mean, yeah, today is just general catch-up problem day, so 45. Did we not do 45? I mean, we might not have. I know I did it, but I guess that was in a different class.
For which day?
On 167 or 168. Maybe that's what I'm thinking.
Yeah, what do you mean?
Alright, use a graphing calculator to graph the function and approximate any absolute extrema. Looking for a graphing calculator. Let's see. So here's my graphing calculator. 3.2 x to the 5th plus 5x cubed minus 3.5x. And I only want to see it from 0 to 1. So window, I guess I'll go a little bit less than 0 and a little bit more than 1. I don't really know what my y value should be, so we'll just see if that works. Now, what did the question ask? Approximate any absolute extrema on the given interval. Well, it looks like there's a minimum right in there. It says approximate, so I could use trace and just kind of guess since it said approximate. But it'd be better if we just went second calc and then use the calculator to find a minimum. Let the calculator do the hard work. It walks you through. Left bound means get to the left of the 0. Right bound, get to the right of the 0, not of the 0, of the minimum. And then guess. And so there's a minimum at x equals 0.4398 and y equals negative 1.061. There is a maximum, but it's happening at the endpoint over there at 1, so that's easy to locate. So second calc value at x equals 1 is 4.7. I mean, I can just tell by looking at it, that's the max. All right, the rest of that problem is sort of repetitive. Use the calculator to find any critical numbers. Well, I can tell by looking at the picture that that's a critical number because f prime is 0 at x equals 0.4398. Like that's how the calculator knew that that was a minimum, because it didn't go, that was the lowest number it could get.